Let's talk about homogeneous linear systems. So a linear system is called homogeneous if it can be written in the form AX equals 0. This is where A is an m by n matrix and 0 is the 0 vector in Rm. So every homogeneous linear system is consistent, meaning it has a solution. And this is because the 0 vector in Rn gives you a solution. In particular, A0 equals 0. And now here you've got to interpret the 0 on the left side as the vector in a 0 vector in Rn, and the 0 on the right side is the 0 vector in Rm. This is called the trivial solution. Now, the homogeneous equation has a non-trivial solution, so a solution other than the trivial one, if and only if the equation has at least one free variable. So let's take a look at example 1 on page 43. You're given the following homogeneous linear system. Right? And so I'm going to write down the corresponding augmented matrix by grabbing all the coefficients and what it's equal to. Right? And now I want to row reduce. So I look for the leftmost non-zero column, that's the first column. And I look at the top entry, that's going to be a pivot. If that was 0, I'd have to swap rows, but I don't. And so here's my pivot, this 3. I'm going to use that 3 to kill off all the entries below. Right? So I can kill the minus 3 by taking R2 and replacing it with R2 plus R1. And I get this. And now I can want to kill off the 6. And I can get rid of the 6 by replacing R3 with R3 minus 2 times R1. And now I like to put boxes around my pivots. So here, the 3 in the upper left corner, that was the pivot we created. And now the 3 that I put a box around next, this is the next pivot we're going to create. Right? I want to use that 3 to kill off this negative 9 below it. And I can achieve that by replacing row 3 with row 3 plus 3 row 2. The first row doesn't change. Second row doesn't change, and the last row now becomes all zeros. And so those are my two pivots, and I notice that this matrix is in echelon form. I want to continue this to push it to reduced echelon form so that I can see what the solution set looks like. So I'm going to start with the pivot that's the furthest right, and I'm going to take I want to turn that 3 into a 1, so I'm going to do that by dividing row 2 by 3, or multiplying by 1/3. It doesn't change the first row. The second row becomes 0, 1, 0, 0, and then the last row stays the same. Now I'm going to use that pivot, that newly created 1, and use it to kill off the entries above, so that 5 that's sitting there. I can achieve that by replacing row 1 with row 1 minus 5 row 2. And that gives me 3, 0, negative 4, 0 in the first row. Second and third rows stay the same. Here's my pivots. I'm done with the 1, and so now I move to the left to this pivot 3. I'm going to turn it into a leading 1, and I can achieve that by dividing row 1 by 3. And I get 1, 0, negative 4/3, 0 in the first row, and then the second and third rows stay the same. And there's my two pivots, and I notice now it's in reduced echelon form. Now let me just copy this matrix over here. I notice that the first two columns are pivot columns. So that means that, or that tells me that x1 and x2 are basic variables. The third column is a non-pivot column, so it tells me that x3 is free. So x3 is going to be t for any t in the real numbers. x2 is 0, and x1 is 4/3 t. So if I want to write that in another way, thinking about vectors, right? I can grab the coefficients on t, so that'd be the 4/3, 0, and 1. And 4/3, 0, 1 times t for t in the real numbers gives me this solution set. Right? This is the solution in parametric vector form. In this case, this is a line through the origin and the vector 4/3, 0, 1 sitting in R3.